All right, we're live with Taylor Thomas, and we are going to be working on Krustlet today, which is a WebAssembly runtime that acts as Kubernetes kubelet, and we're going to be adding logging capability to waSCC actor, which is, it's probably all of the terms that we could throw into one sentence. We got them all. Did we miss any?
waSCC.
Oh yeah, there's waSCC too, and Rust. We throw Rust in there in Kubernetes, we've got everything covered. So
All the acronyms and buzzwords to your heart's content.
exactly. Just make sure that our Twitch chat is chatty. Good. All right, so we're on a Visual Studio Code live share, and you can see the code and everything. Assuming it's a yes.
Yes, I can see everything.
All right, cool. I added a crate called waSCC logging, and I copied over the default logging capability provider that I built for waSCC itself. And I believe what we're going to do, and we need to talk through this, but I believe what we're going to do is modify this so that it creates a new log for each actor. So I will speak out loud about the waSCC provider as a way to remind us of the way I think things work, and then you can tell me how far off I am, and that should help us figure out what the right thing to do is for logging. So the waSCC provider is a little bit different than the waSCC provider, because the waSCC provider starts a new instance of a waSCC module for each invocation. But the waSCC runtime starts a host that has actors in it, and that runs one instance of an actor for the entire host. And that means that for purposes of logging, our waSCC logging provider want to capture logs individually per actor, because an actor would be analogous to roughly a pod in Kubernetes world.
Yeah, right now, technically, actor would be a pod. So you could have multiple actors coming from the same pod.
Have multiple actors in the same pod?
Yes, because each container is spun up separately. It's added in separately, I should say. So if we look at the if we look at the waSCC provider inside of the code there in librs, which is where I'm at, you'll see.
Okay.
You'll see that we have each container in the pod. We go through and we spin up a waSCC actor, which is this waSCC run HTTP, right. Which when we actually go down to that function and look at it, then we have the actual, oh, hey, here we're going to get the environment that's going into this, and then we're going to run the waSCC stuff. And that waSCC run is where you're actually creating a new actor for each one. So technically we get an actor per container in a pod.
And when you get, when we do logs, that's giving you logs for a container.
Yes.
In a pod.
You have to specify the container, though I think in 118 or 117, I can't remember which one, they were adding in the ability to just be able to grab all the logs from all the containers in a pod. But in at least the old way of doing it, you had to specify a container if there was more than one in a pod.
Okay. All right, so do we have a unique ID? Well, we're going to want to have the containers logs separate anyway. So let me back up just a little bit and go into the waSCC logging library. In waSCC logging librs, there's a implementation for logging provider, and then there's a configure function. And that configure function is the thing that accepts information when this is instantiated. And an example of that would be for example, of a usage elsewhere would be in the WASC, the WASC provider. And start the WASC provider, it adds the HTTP server capability.
Yes.
And then somewhere we tell it where the port thing is, configuration for the.
Yeah, that's down in the WASC run HTTP. You'll see that you pass in the environment stuff, and when you go in there, those envars, yeah, that's where it's getting the HTTPM with the port.
Perfect. So that that call in WASC run creates a host configure call on line 218.
Yes.
So that sends in the environment.
Yes, it does.
And that configuration that's a trait that every WASC provider has to have. So for us, we're going to want a configuration for the logging provider that tells the logs how to store for each WASC run.
Yeah, which should probably be at the full. So that'll be probably stored at the WASC provider level, because everything from that provider should use the same kind of logging system.
Yes.
So then it would be passed into, and then we create the logging provider for that actor. Is that what you're thinking of doing?
Yes. So what I was thinking of doing was keeping a cache. I don't know all of the great rusty terms, but keeping a map of the actors that we have running and handles to IO writers, in Rust term, the handles to the writers, file handles that we use to write those logs inside the WASC logging module. And that way, when a new actor starts, we have down here look at roughly line 105, 106, 107, where it's actually doing the logging. This is where it responds to a log message. We're sending, we're actually just writing error to the Rust regular log crate. Oh, somebody just mentioned my mic is too quiet, so that's probably better now. So we're writing to the regular Rust log crate, but we don't have to do that. We can write to a file, we can do whatever. Part of the message that we have is the actor. The actor is the token for the WASC module. So we can use that to separate these messages and put them in the right place.
Yes. The other thing here with the handles, so if you go to the WASI provider, there's something that we wrote there that was meant to be abstracted out to everywhere else, actually probably as part of this work here, which makes this probably a little bit more complex than we were intending. But if we look in the WASI provider handle module.
Yep, I was reading that this morning.
Yeah, this is the thing that we wrote. It's not a perfect API, but it was the combination of a bunch of stuff we learned in a previous exercise of trying to handle these processes from a little bit lower level. That's called a CRI if you're in Kubernetes land. And so it's taken some learnings from that, and it has this runtime handle. And it is generic enough that it should be able to be used for any provider, in which case we'd move this probably over to the kubelet crate, because it would belong there as something for the provider to use and import. Because this has the ability to, you can pass in anything that's a reader to be used.
Okay.
Which is what we'd want. Like, so for whatever logging we're setting up, we'd make it so that it could return a reader. So now what we'd probably want to restructure is to do something similar as what happens in the WASI provider, but in the WASP provider. So in lib, when we do the wasc run HTTP, the result should return a handle, a runtime handle to the given actor. And then we can implement all the things that allow us to stop an actor and remove it and all those different things for that handle. I think it'd probably be the best option here.
Yeah.
And it would allow us to work out the kinks in whatever we defined as the API for the handle.
Oh, very cool. And that reminded me when I was digging through our WASC provider today. Where's the actor? If you look at the that's a test, I'm sorry. The actor ID, we had hard-coded somewhere. There's the waSCC crate has the ability to read the JWT token out of the extra headers in a WASM file that's signed. So we can use the waSCC crate to read that actor ID out of the WASM file. That will just save the trouble right now, I think.
We pull it from the pod.
Yeah, we pull it from the pod, which it's
not
actually
necessary. That's better.
Yeah,
because right now the way we have that, it'll set up, it makes it so it's hard to run more than one actor per pod, even though we have the ability to do it. So that's probably the better option anyway.
Yeah, very much so. So yeah, that's the waSCC lib, and that should be really easy to add too. All right, so where do you want to start? Do you want to start by, are we going to this handle code out?
Yeah, I think it'd probably be best to move the handle code out first. That'll also give people who are possibly new to Rust who are listening kind of an idea of how modules work and where they go. So I think that'd probably be a good first thing to start on, and make that a more generally available type of thing.
Oh, good, because I'm definitely
the one thing we might want to do. The one thing we might want to do before we start is there was a big PR where Ryan, another one of the maintainers on the project, has added a bunch of docs, and yeah, he just merged it about 6 minutes ago. So we might want to pull that down and then do the new branch, because he refactored out the crates to be a little bit more sane, and so that way we put this all in the right place.
All right, was that just was merged into master?
Yeah, it was merged into master, so we should just be able to.
Okay.
Yeah, we should just be able to pull the branch off of that.
I've already made changes in this branch, so I'm going to commit my. There we go, and force cargo lock.
That's fine. Generally, we've been safe to remove that and just rebuild with a cargo build. Just trying to merge the lock file is a little bit nasty, but I think at this point we have the newer one, so it might be easier. But just for easiness right now, we can.
Okay.
We just redo a cargo build and let it do its thing. Is there conflict in?
Oh.
There's a conflict in TOML as well. Based on the output I'm seeing in your terminal, it says merge conflict.
Right here. Both.
Yep, that's the one.
All right, we'll let that build. Cool. All right, so we get the benefit of all of Ryan's docs, which looked really pretty.
Yes, it's really nice to actually have some full docs.
Look at all those.
Yeah, we had some nice usage docs for like in the actual docs folder, but we did not have them for the actual crate. So that's awesome. Really nice.
Good job, Ryan.
Yeah, and so I think what we do, let's go ahead and move. So now the kubelet, inside of kubelet, we have the, it's called, it's the provider module inside of kubelet. And so what we're going to want to do is add probably that into the provider crate because it's tied into help. It's like a provider used type, and then we can export that type in lib.rs.
Okay, so for me who understands Rust modules almost not at all, we would take code from the handle.rs file and put it in that provider file.
Yeah, I think everything in handle.rs should, it looks like everything inside handle.rs should go over. So we can probably move the file, and I'm just trying to think what would be the better cleanliness here. If it should remain a separate module, that's just, maybe it should remain a separate module inside of kubelet. And then we'll just document it that it's meant to be used as a provider. And then I think when we get to the PR review phase, when we have somebody review it, I'm sure Ryan will come in and give us his professional opinion on where it should go to make it the best or cleanest Rust code, idiomatic. Okay. So I think we just keep it separate, so we can just move. I'll just go ahead and move right now. I'll move handle.rs up into kubelet source, and then we're going to have to change a few things inside of there because we were importing kubelet into the waSCC provider, and so now we just need to use crate provider, and then crate status and crate pod wherever it says kubelet. So just those last three here at the bottom. So this obviously will actually build how modules work is that you have to basically say that they exist in the main crate or the in the other modules. And so lib.rs, those new to Rust, can you can see like all the documentation for it. And here's like where you basically, it's the top level like entry point into your crate. And so right here what we have is it's saying we have all these types. And so just say that this exists. So we should probably make this pub
mod handle.
Because people need to access the things in there. And then to make it a little bit nicer, we probably want to do pub use handle runtime handle. So that makes it so now you can import this as kubelet : runtime handle.
Oh.
And I think, so I think that should do it. Just checking if there is anything else that we needed to from there, because I don't think there is. I think it's just that one type. Oh no, there's the pod handle as well. My bad. And that should do it. So now I'll see if that compiles. My a little bit behind. So
well, I'm still building after the cargo lock move anyway, so it's going to be a minute before we're able to build anything anyway. But we can go in and change the waSCC provider to import the right stuff, right? waSCC provider.
Let's you drive.
Right, so yeah, librs in the waSCC provider needs to use kubelet pod handle.
Yes, kubelet pod handle.
live streaming and this giant cargo build. It's slow. All right, then let's take a look at Azure Runtime. See if
you'll find the runtime handle in there. So the way this is all managed is the runtime handle is wrapped by the pod handle. Because you want to handle to your whole pod at a single time and then be able to like go through and request the things that you need.
Oh, okay. Makes sense.
But that's not set in stone. If we don't like any of it while we do this, then we can immediately change it. Do something different.
All right, so we need to get rid of the mod handle in Azure Provider librs because it doesn't exist anymore.
Yeah, that's correct.
Okay. Getting close on our build.
Sweet.
Maybe close is a stretch.
We're almost there. The crane lift takes a little bit, but then after that, it's pretty much done. Because I actually looked into this, the crane lift is doing a lot of like generation of lower level instruction sets and things for each type of each type of architecture. So it takes a little bit.
I just
we're
just taught myself about build RS because I was going to do some generation. It's totally random while we wait for this to build. The Azure Functions now supports custom runtime, so any executable that can run an HTTP server can now be an Azure Function runtime. And I built one on Rust and was going to have it automatically generate the Azure Function definition. I couldn't figure out how I was supposed to do runtime generation in Rust, and then I found build RS and got excited.
Yeah, build RS is super handy. You can do all sorts of crazy things with it. Also, it looks like when I tried to save pod handle, it didn't save properly.
Yeah, that's really strange. I've seen that before where the remote save isn't the same as my save.
It's okay. I will. I'll drop out of the collab session.
No, it's good.
Back in.
The
it was giving me some other issues too. I'm jumping back in.
That looks much better in the build too.
Yeah, it does.
I was a little nervous when you said we were going to move this handle code out to the kubelet, but it doesn't seem like that was much of a big deal at all.
Yeah, we're just missing docs because we've changed it to a public module now, and so we'll have to document that to have our tests pass before we actually open a PR. But that's fine.
Yeah,
everything else is silent.
That makes sense. I don't know what happened, but your picture got really small screen share, so it made you eat like postage stamp size.
It's okay.
Isn't fair.
that's fine to me.
Considering you're the only one of us who knows how to code.
Well, we're still all kind of a whack-a-moling with Rust a bit here and there.
It's fun, you know, while we're just BSing and waiting for things to compile. I was afraid that it would take a long time to pick up Rust, and I still have problems with lifetimes. Oh my gosh, I got nailed on a lifetime problem this morning. But other than that, I'm doing pretty well.
Yeah, it's a bit I always consider the curve to be logarithmic on Rust in the truest sense.
Yeah.
It has a really hard initial thing, but that's what's so powerful about it, is because the compiler's checking you on so many edge cases that you would normally miss with other languages. You have to put in a little bit more effort up front to understand that, one of those being lifetimes and borrowing and all that. But once you kind of get a grasp of it, like I still don't have a total grasp, but then I'm able to go in and I can like get over that hump of the logarithmic learn, and then it's kind of a bit more of a normal climb from there.
I haven't seen better compiler error messages ever. Even though some of them are just a little bit cryptic if you don't understand all of the concepts of Rust. I mean, generally, when I do something wrong, the compiler tells me exactly what I did wrong and how to fix it. That's really awesome. Okay, our compile actually did. Why do we have some codes?
Yeah, because I think we're still in the middle of a rebase, right?
Oh.
So we probably just...
Whoa.
I think that was just a copy paste. It could have been
okay, we're better.
The screen
better. All right. So the WASI provider is happy now. It talks to kubelet version of the handle thing.
Yep.
And should be able to go start adding that stuff to the WASC provider.
Yeah, we can probably commit this right here as a separate commit, since we had to move things around. So we'll have to add the kubelet rate and the WASI provider. Oh, and then we have to mark cargo.toml was merged. We need to commit cargo.lock as well. I think it's just get rebase continue, right? Or were you merging in?
I merged upstream.
Oh, you merged. Okay. I missed that part.
Okay, and I left the logging crate out for now because it'll be a separate commit.
Yep.
Okay, so now we can add the handles to WASC provider.
Yeah, so now we should be able to use them once we do the logging. So I think we can focus on the logging, like what you said, with the logging crate. And then once we got that logging stuff all set up, then we can go implement in the WASC provider, the like actually calling in the log setup and provider for each one.
Okay, so logging. I don't have the first clue how to have a cache that's happy with threading. So I'm going to let you lead that part. Basically, in the logging provider configure function, that's where we're going to store whatever handle we've got for each actor.
So is the logging provider? So the logging provider needs to handle all actors.
Yes.
Okay. So then, what we'll probably want is just. Let me see here. I think that based on this, because it's going to handle all the logging for it. So basically, if I understand this right, because you worked on all this code to put this all in, when a actor logs, it's going to send it to the logging capability, correct?
So,
and the logging capability actually logs.
Correct. If there's a logging capability provider registered, it will log. But just like all the other capabilities in WASC, if there isn't a provider registered for it, it's a no-op. So actors that log, and there's a logging provider running, logging provider will receive those messages. They're basically RPC calls. And that code is, oops, down here in the handle call, starts at line 90. So any RPC call that comes in, check to see if it's a configuration call. We're going to need to add code back here because I removed line 96. That config vals is the thing that's going to tell us where to store log files eventually.
Okay, so we don't have to pass that in when we construct this provider. We'll configure it later.
Correct. And you
okay.
Show you. I'm going to cheat here. Oh, can you see my terminal? If I open Vim on my terminal, can you see it?
Well, I haven't tried it. We can see what happens.
But we're sharing. Oh yeah. So open the.
I can see your terminal though.
Let me show you this. So we're cheating here. And here is an example log, an actor that loads logging. So this is the generic logging provider. And that's right here on line 12. We add the native capability for the generic logging provider. And then on line 15 through 18, we're configuring the first actor that, what's the actor called? Test logging signed.wasm. So we're configuring that actor and telling it that for the HTTP server, we want port 8081. So what we'll end up with is a duplicate of lines 15 through 19 for that actor, and we'll configure WASC logging, and we'll give it a hash map that has a log location of some sort. Information about what to do with logs. And since we can only pass a hash map back and forth, the WASC logging crate is going to own those file handles, or whatever they are, the streams.
Own the file handle for the
logs.
For the logs. Yes. Okay, so then to just state the problem back. So what we're going to try to do here is we're going to want to have some sort of way to map the actor's ID to a file that then will send things out to when we get a request from that actor.
That's exactly
right.
It. So we'll start with a configuration call in our logging actor or logging provider here. And that receives a hash of values. And so it's going to be, I guess, it's going to be an actor ID and a log location of some sort, path.
Yeah, so we're going to need it. Yeah, we're going to need probably just the actor ID, which is the public key for it, right? Mm-hmm. So we'll have the actor ID, and I think that should map to a reader. And so if we're going to make this as generic as possible, because one of the problems I have with the raw wasm time, stuff is that you can only pass in files. as in standard OS file handles. And so what we want to do is avoid that and just make it as flexible as possible. That way somebody could pass a buffer if they want to. Let's see, I was just checking the chat here because we also have Kevin in the chat, who is the principal maintainer of
outer message. I'm sorry I interrupt you. Saying that Kevin is
is basically the main maintainer for WASC. So good to have him commenting on this. So
it's like a little angel on your shoulder telling you what you're doing
wrong. Says so. Yeah, outer message. So config vals actor is the actor ID.
Beautiful.
Config vag.
Okay.
And that hash map contains what again? Sorry, I'm having a hard time keeping everything
the hash map
in my mind.
It's just it's got the actor name and then a list of, or a hash of values. So those are the values that we set. They don't have to be anything specific. Choose what we're sending in. So for example, in that HTTP provider, we tell it what port. So there's a key value pair for HTTP port. And in our case, we're going to have a key value pair for log handle.
That's going to be interesting because then we can't pass in something generic because we're restricted to a string value.
Yeah, and I tried to say that earlier. I don't think I said it well enough to make the point, but yeah, we can only pass in strings, and that means that it's going to be you have to pass in a path or something, or you could pass in a file name that we use as a relative reference from a known location.
So I'm thinking what we do is something similar then to what's in the waSCC provider, which is we use the temp file crate, and we can create a named temp file that then we just hold on to.
Okay. Yeah, I saw that this morning.
I'm trying to think of because the other thing we're going to have to handle is with the no pun intended, but is with the handle part of this. We need to be able to return back in the waSCC provider. We need to be able to keep a handle that can tell us like where we can go to grab our logs. And so we need a way for it to be able to pass back. Like basically both things need access to that file. And so there's no way for us to hand back a file handle to the main process when we add it.
Correct.
Though actually, so there's some dangerous stuff. Let me double check the documentation here, and I can send a link so you can bring it up one second. There is some interesting things around temp file about guarantees. Because I think, let me check here. In waSCC provider, we're doing we're doing new in, and then we're doing it in like a specific directory. So then when you have that temporary file, I will send you the link for this documentation as soon as I get to it. Okay, I just sent that over to you. So the name temp file, you can get the path from it. Yeah, you can get the temporary file path. What it refers to is there's some security concerns. There could be some possible security concerns there. And so you can end up like recreating a file that'll be opened by that could be created by another program. But I think that might be our best option here is that in the external scope, so in the main waSCC provider, we instantiate the new temp file, and then we get the path and we pass it out to we pass that path into the configure call.
Okay.
The one concern I have left is that if once that named temp file goes out of scope, the file's deleted. That's part of the drop logic for named temp file.
Mm-hmm.
And so there exists a possibility that you could remove the file and then it would try to write to the file that doesn't exist anymore. Now that shouldn't happen because when we stop the log provider, when we stop, we're going to have to, well, I guess when we stop, we're going to have to do a configure call to the log provider and tell it to drop that from its map. But it should be done anyway. It shouldn't write anymore because the actor will be removed. But that's just something I guess we should keep in mind if we see any possible edge cases. So I think that's probably our best option is to use the named temp file outside, passing the path through configure.
Okay. All right. Well, let's start then. We're going to go into the WASC provider.
Let's just assume. So I think which makes more sense to do first for you, the WASC provider or the WASC log?
I think we should build what we need in the provider and send it into the log.
Okay, let's do that. So first thing we'll need to do is add the temp file dependency. I'll go ahead and do that right now.
Okay.
Just copy it over from waSCC. And then I'll let you drive from here.
That could be a mistake.
Well, that's what these are all about, right? We make mistakes together.
Okay, so the WASI provider has handles and a log path. Is that log path probably going to be relevant for us?
Yeah, so log path is yeah, the log path is something we pull in from the data directory and we construct. And so we just have like a hard-coded like name of the log directory that goes into we just join it all together there. So we can probably copy that logic wholesale.
Okay. Which is in log path or
it's yeah, it's the
new.
It says let container path. Then we have sorry, that's different. Sorry, let log path data path dot join log your name, and then we try to make sure it's all created. And so we just have to have the same.
It's the module store implementation for WASI provider. Do we have the same thing for WASC, I wonder? Oh, we do.
Yeah, we do. It's there's that new call is the same everywhere, so it should be able to infer which kind of thing you're doing, so that anyone can use a store that they want to.
Oh.
Also, Kevin just pointed out when we get to it that we can have a capability provider take regular environment variables that are scoped to the provider and not to actors.
Oh, nice. Might help. All right, so we have log path, we need the log dir name to be here. Right, and then create the log path.
Config is coming in from the new function.
Right now
it's passing in like, yeah. So you just have to pull off the
whole underscore thing. I didn't realize Kevin pointed that out yesterday that compiler just ignores it if it's got underscore. I figured it was just like a naming convention, but no, much more important than that.
Yeah, it ignores it, and it's actually helpful. I've seen it used in cases where like you're you have like a result that you're ignoring on purpose, but you want people to know what it's doing, and so then you can underscore and give the variable a name even though you're never using it, so people have context about what it is.
All right, so we've got our log creation, that should be okay. And then we return our handles, store, and the log. So that all looks happy. All right, what's next?
So now that has the log path, that gives us a basic way for where we can create the temp file for each actor. So now we'll probably have to go down and inside of
add.
So we're going to probably have to make waSCC run HTTP. We're going to have to make those things a self. So like the methods inside of, we'll need to make those so they're not separate functions and have them be functions that are inside of the actual impl.
Okay.
So that we can access the stored log path, or we can just change it so that it accepts the log path. Either option will work. I think we might just want to do that actually, now that I'm saying it out loud.
All right, so we would add
a log path to the
as a parameter for the waSCC run HTTP.
Yeah.
Which one gets called waSCC run or waSCC run HTTP?
waSCC run HTTP is the one that gets called, and then it calls waSCC run.
Oh, okay. Does this HTTP env get used? Did you drop?
It gets passed in. Yeah, I dropped out. It's the rebase screwed up the live share for me, so I'm just reloading it.
Oh.
That HTTPM is being used when you pass it into the waSCC run, I believe.
When you get back in, I'll ask you to show me where, because I see where HTTPN is created, and then they insert the port. I don't actually see, unless it's a closure.
Yeah, I still have all the wrong data showing up on my end.
Oh, kill Krust analyzer, Krust RLS.
Like I'm talking about the actual text output.
I can end the live share and we can start a new one.
Let's try that. I think that's what happened.
Okay. Stop it.
Because we all know it wouldn't be a live coding thing if something didn't go wrong.
I still have no complaints about the live share stuff because it's
no,
freaking amazing.
me neither. I love it.
It beats joining a shared TMUX session every day.
Let's try joining back in.
You're back.
And it looks like I'm seeing all the right code now. Yeah, there we go. Okay. So,
yeah, in waSCC run HTTP, we create this HTTP M, which is a hash map.
Yep.
And then where does it get used? Is that passed in as a closure into waSCC run?
Trying to figure that out.
Because how can it? Yeah, those are the only two places that's mentioned in this file. So,
But could be leftover debug code, and it's not getting caught by the compiler because it's HTTP-M is being used right here, even though we don't use it elsewhere.
yeah, it seems like this is useless. Or we're wrong. Bars. So when we do waSCC run HTTP,
We're passing in the environment variables for the
passing in the environment variables for the pod, right? The ones that are declared in the Kubernetes configuration.
Mm-hmm.
All right, well, that's fine. Is it fine? Yeah. As long as there's a port.
This is one of those things like let's leave it there for now, and then we'll go ask some people later.
I think we should comment it out and see if we can build.
Yeah, I think we will.
Yeah, builds just
in the
fine.
meantime, yeah, so that builds just fine. We'll take it out, and then if anyone says, "Oh, hey, we should have that," we can.
That's what Git's for.
Do it. So, yep, that's what it gets for, and PRs are for. So,
all right, cool.
I think we're covered. Okay, so I think what we should do is then just probably pass through the log path.
Also going to need the capability, or I'm sorry, we're going to have to pass in capability for logging. So this HTTP capability up at the top is declared probably as a constant. Yes, so we need a log capability. When we do waSCC run right now, we're passing in capabilities, which is a vector of capabilities, and we need 2 of them now.
Yeah, see, so I think HTTPM was the thing that was originally passed in here because, let's see, because when you go down, you look at waSCC run. How is it using each capability? So capabilities.iter.try for each. And then it says host.configure.
Yeah, that's
passed in the environment variables.
Yeah, and that's what Kevin's mentioning, the capability provider can take the environment variables. So we're going to have to inject, we should have kept that code because we're going to have to inject the In fact, I'm going to back. I'm going to have to inject the log location into the env.
Yeah. So what I think we do is we pass. I think we change just these HTTP, the WASC run signatures to take the log path. And let me check, is that coming out as a path buff or a string?
I think it's a path buff.
The path is, no, it's just a normal path, which you can turn into a path buff. It's a reference to a path, is what the path function returns from a named temp file. Okay. So we should probably just have it be nobody else is using these functions, so we might as well just have it take a borrowed path. Otherwise, I'd say maybe we do like an asref path. So like right here, we'd say log path is at path, which I don't think we have imported, so I'm going to import that up top.
Well, here's a good question. While you're typing, and does stuff asked, he's trying to decide whether you should learn Go or Rust, and both of us have done both. So that's a great question. I'm not sure that there's a right answer to that one because they're both valuable languages and kind of depends on the space you're working in. A lot of the cloud native stuff these days is in Go, and Rust seems to have more strength in closer to metal stuff, but people are kind of branching out with Rust. Rust is definitely harder to learn, in my opinion, than Go. But I don't think you'd be wrong learning either.
I mean, what my general feel on it right now is they kind of, I would choose Go for anything that's going to be small and like a true microservice, and anything that needs to be just done like a super quick a piece of like a super quick service that you're going to build, or like a microservice. I found that Go becomes a little bit more unwieldy the bigger it gets, and so then what I generally find is that I like using Rust for some more of those, because then you have a little bit more flexibility with things like generics. Like we found that like writing one of the things we've liked about having a kubelet kind of implementation here in Rust is that we have these like generic providers that could be swapped out, which you can kind of do to an extent with Go. It just really depends on the project, is what I've found. It's a great question to have, but I mean, there's no reason to not do both, and especially because Go is fairly easy to pick up and be productive in a short amount of time.
Yeah, Rust, the
after that
curve is definitely steep in the beginning, for sure. Yeah. Cool. All right, so you added our log path, and
yeah. So now what I'm thinking we do here. I'm just trying to think if it's worth the overhead of doing an @mute vec, so that we can just do a capabilities.push and then push in the log path capability for it automatically. I think that @mute's in the wrong place. Let's see. Anyway, we can check that in a second. So what do you think is better? Do you think it's just better to try to like create a new vector that we add the capabilities into?
So this looks like I don't remember. This is in Rust, but it looks like a macro that just creates a vector on the fly. So
yes, it does.
Seems like could do this.
Well, it's just thinking if anyone, I don't think anyone calls waSCC run. Let me check. There's a test function that does. But that's it. Just in the WASC echo.
Okay. It's fine. We're going to have to fix the one that does the run HTTP anyway.
Yeah, so I'm trying to think like what would be the best option here, because I guess the idea is that if somebody comes in here later and modifies, if we wanted something that didn't have an HTTP capability, which I could see us doing this, like if there is no exposed HTTP port, then we won't expose the HTTP capability for it. But anyway, I could be wrong. So maybe the easiest way is just to make this. Yeah, I don't know what's the nicest here. So we can either clone the capabilities object and add in the path to it, or we can just make this app mute, and then inside of here we can do capabilities dot push, and then we can say capability name log capability.
Oh, I see. It needs.
And then we need a hash snap. So we'll need a quick. Yeah. So let mute. Close login. Actually, this should probably be a constant in the WASC logging. The WASC logging crate, wouldn't you think?
Oh, yeah, that makes sense.
Anyway, well, I'll keep it there for now, and then let's just go at it just to make sure that this works. And then so we say the log path, and I'm gonna have to look up because I think you have to do 2 OS string. And I don't have autocomplete on here.
I have auto because it's autocomplete for me while you're typing, which is pretty awesome.
Oh, that's nice. It's not autocompleting for me. It's
no OS string. There's 2 string.
Yeah, there's 2 string, and then there's 2 string lossy. So the thing is that's the difference. Is a string, like the capital S string in Rust, needs to be valid UTF-8. And so when you get to just like a string, like what this returns is an option to a borrowed string. And this needs to be, I think, a string to string, right? Yeah, it needs to be string string based on what I'm seeing up in the old code that we had for the HTTPM. So this needs to be hash map string string
Generics.
Yeah, and Kevin was talking about that. Like if you call 2 owned or a 2 string, it becomes a string, which is fine. The problem is that we need to probably just do a 2 string lossy, but that returns a cow, a copy on run. Be invalid. I mean, famous last words, right? I think you can call the 2 string on a cow. We can get an owned. I'm trying to remember.
Shrugging and shaking.
I'm looking into it. Let's see. Yeah, there's like an into owned. So I think what we just do is unwrap it. And then we just say to owned. I think we cover. I think we can see if that actually happened. But the thing is we're passing in a log path that we already constructed earlier, so it shouldn't be a problem. Um, yeah. So now, like that should be like the way we can get this in. I'm sure there might be a cleaner way of doing this, but it works for now. And so that gives us the environment that we need.
Built.
You're in WASC host. That's why you're not in Krustlet on the in this terminal.
Oh, well, that would explain a lot.
I'm pretty sure this at mute is wrong, but I could be completely off. While he's doing that, looks like there was another one, another comment on just dependency management question. And not sure if you saw that.
Do you feel like you get problems with dependency management in Go? Yes.
Yeah, that is my number one problem right now. It's just a pain, especially like if you have simple dependency trees. It's great and it's super simple. But once you do anything complicated, and especially if you're doing things in the Kubernetes space, it becomes an absolute nightmare. Absolute nightmare to handle. Let's see. Unexpected close delimiter in kubelet. Source lib. That looks fine to me. Make a change and save again. As you know, things got out of sync. Yeah, it's your local RLS. It has a lock.
Yeah, that's crazy. Which I guess it's cool, but still crazy.
I think that works.
Box warning. Nope.
Okay, can't
that's
insert
good.
type.
Those are just
that's fine.
things.
Yeah, these are fine. Okay, sweet. Okay.
All right. Back to the WASC provider. So we need to add the RW lock references.
Yeah, to the hash map string pod handle. We do that in the WASI provider. Let me just go copy that. Wait, handles, yeah, handles default equals. Standard sync arc and standard, and then it's Tokyo. Yeah, Tokyo sync read write lock.
Laptop here. Start a little cranky about all this stuff we're asking, but
Okay.
All right, so WAS provider needs a pod handle. 72.
Yeah. So I think what we do, we need to pass in all the new parameters that we need to on those lines. I'm going to follow you. I got unfollowed from you for some reason. My hands are off the keyboard. I'm just going to watch through. So yeah, I think what we need to do is go, we're going to need to handle, yeah, we can look back here, copy some of this, but we're going to need to basically make it so the run WASI, the run WASC HTTP and run WASC return, well, it should technically just be run WASC returns it.
Confused on handles, just says default or
yes,
WASI.
Because it's just creating the arc read write lock and hash map, an empty hash map for us just by default.
Okay.
So that we don't have to go through and say arc new, read write lock new, hash map new, all the way through. It just is doing that all for us. So that's fine. The big thing is going to be
reference for that, though. That
reference in WASC provider.
Yeah, WASC provider doesn't know what that means. Can't resolve standard default. Type annotation needed. Cannot resolve. Another default.
No, there shouldn't be. Handle should just be able to default should just work there. Oh, it's probably because we don't like insert anything into it in all the other functions. We need to go insert something properly for it to ascertain, to do what it needs to do to figure out, infer the type. So I think we just go work on the other stuff, and that should help solve it.
All right, so where are we passing in the handles in the WASI thing?
So inside of WASI here, I'll go there if you want to follow.
Okay.
So inside of WASI, how this works is, and it's going to have to be a little bit different here for WASC. But what happens is we go through and we get a handle right here. So we're going to have this container handles, and it's a map of the string of the container name to that runtime handle. So this is the runtime handle type that we moved earlier, not the pod handle type.
Okay.
This runtime handle, we get a whole map of them, and then we create the pod key that we're using to latch onto this, and we create a new pod handle, which contains those container handles and the client that we need to be able to update the status along with the pod that we're managing. And so what we need to do is what happens in here, and what we'll need to do in a WASC provider is in the runtime where we set up all of our runtime stuff, it returns down here. So we have this start, and it returns the runtime handle. And so what we're actually doing is just creating the new handle from the status stuff that gets sent through. The join handle from Tokyo, and then getting the file from the temporary file we've opened, which is this is the handle back to the logs.
Yeah, okay.
So what we're going to need to do is figure out how we can map these things into the WASC runtime. So basically what we need to be able to generate is a status receiver that is where the running actor can send status updates or whatever can tell us like what the current status of the actor is. And maybe right now that's like a no-op channel. Maybe we don't have an easy way to do that. I haven't really dug into it yet. We're going to dig into it right now. The handle that which we should be able to, the handle for us. See, this is where I might have to rethink the API because the handle, you don't get a handle out from waSCC. You just have the stop function.
I have a hard stop at 4 o'clock, so 15 minutes too. I'd just throw that out. Get too deep on any other thing.
So this is looking like where we might have to do a little bit of a refactor because of this handle. This handle type is assuming that you need like a join handle to listen on to wait for it to stop. And so what I think we'll need to do is maybe refactor this to have some other way to indicate that we can stop something. Because if we look at, sorry, not there, the handle stuff, what it's doing under the hood is just going to call, like right there, there's nothing actually going on, but it like waits on the handle that it's given so that it can stop the thing. So what I'm thinking we do is we probably pause this for now, and I think we go to the waSCC logging and implement the waSCC logging, knowing what we're passing in right now. And then I think we can revisit this again and how we want to refactor it to be able to handle any type that we want to when we get to next week, since we need to stop in 15 minutes.
All right, so if we go back to...
Here, I'll stop following. I'll follow you.
So if we go back to waSCC provider, where we
we have it right here. We also should remove that extra capability we added.
That was me. So we added the log capability with the log env, and we know that log path is going to be the environment variable. So let's go into logging, and we're going to
let's get that pub constant set.
Yeah.
That has log path. Pub const was right.
like so.
Yeah. And so then this is the lib. So we should probably go back to, we can at least get this done in the waSCC provider. So we'll need to add the waSCC logging crate to the waSCC provider in the cargo.toml first. You already did though, didn't you?
Question.
No. Did you add it
at
the top level? Okay, that's probably, so we should probably remove it from there because we don't set it up directly in there. And then paste it in waSCC logging. I mean, sorry, not in waSCC logging, in waSCC provider. That should just be dot. There we go.
Just follow after you and hit Control-S because it's saving on.
Oh, dang it. Yeah, so now we can import it here back in the waSCC provider. Yeah, waSC logging. That's what it is. Underscore. It automatically underscores it.
That called
Log path key, I think. Let me look. Yeah, log path key. You don't need to do the full path because you imported it. So you should just be able to say log path key and you should be okay.
it's okay.
You're still gonna. That's gonna still be all compilation errors there, I think.
Okay. And back to logging. Now we have this configure call we need.
Yep.
Need the vals.
That capability configuration type, I'm assuming, is what we map.
We need to fix the big call. It's not actually using
Okay.
big now.
Okay, so then we say we're configuring this, and we can take that.
We have all that stuff.
Yeah, and I think it's config vals.module is the hash map, according to the chat history from Kevin.
That. And
Oh, do we need to do config.into? Maybe it'd be like this. I think you have to let it know what it's going to be let.
colon equals. What's the colon equals for? Right, and go.
Oops, sorry. Yep, went back to Go. What happens when you maintain a Go project and are writing a lot of stuff in Rust. And then you say config.into probably. And this would be conf. That give you better things?
Now we have well, I don't know.
Oh, this should be.
Wait, I gotta save it.
Yeah, because apparently my saves are not working. Is there a reason we have to have the impl into right here,
no
though?
idea.
I mean, we can see what happens if we do this. Did my save work? Oh, this should be bigger config.
RLS doesn't have any problem with it. Cargo check. Actually, I think that's fine.
Sweet.
The only error we've got now is the self-duck. Oh.
I don't think we need the map. We're just gonna, we have a result, so we should check for, we should do a question mark there.
Question mark?
Yeah. Well, let's see, because it returns evacuate, which is what configure dispatch. No, wait, where are we at? Handle call does return evac. So you can actually just do that. Return. Wait, so this is, oh no, so the whole if statement was returned. So I was wrong. We don't have to do it like that. We can do, oh, we jumped around. There we go. So I think what we do here is we go self.configure, and that's it.
Might build. Nope.
Well, yeah, we're going to have, yeah, so that build, yeah, because we're still going to have the compilation errors elsewhere. Yep. So I'm going to delete that comment that we don't longer need. So yeah, that should do it for us.
All right, so now we have the right config values. I got to stop following you. It's crazy. We have the right config values in our configure function, and that's where we can start up next week on.
Yeah, we can actually do the real configuration. Yep. So we'll have to like put the hash map inside of the provider and all those things.
Exactly.
And then we can figure out how we want to refactor the handle so that it can handle, I don't know what other word to use there, properly use the things that it needs to.
Just all of this. All right, so I'll push that up to my fork, and that is awesome. Well, thank you so much for teaching me more Rust today. It's a lot of fun. We have a good portion of this set up, and it's nice that the waSCC provider gave us a good pattern to follow and some code to factor out for the handle stuff.
Yeah, I think we got really far. We're just basically down to glue code and then just making sure we actually get the right logic inside of the logging, which is probably the easiest part of this. The hardest part is going to be that refactor.
Let me throw the waSCC URL up on the screen. This waSCC.dev, that's the runtime for running WebAssembly as actors in a secure manner. And then Krustlet, the code we're working on now, github.com/dslabs/Krustlet. I can't forget Taylor's Twitter. Follow Taylor. Taylor _OF Taylor of Taylor. And I really appreciate everybody watching today. And then once again, I appreciate your help, Taylor.
Thank you for having me, Brian. It's been fun.
Thanks.